Good morning, class. Today we are going to discuss about research variables. I know all of you are now really excited for a fun learning session. Now, are we all set? For this week, we will journey towards understanding on the nature of inquiry and research. After going through this lesson, you are expected to differentiate kinds of variables and their uses. Humans are naturally curious about anything and everything. We always ask questions and test theories about ourselves, others, events, the environment, and the world around us. Research is asking questions and looking for answers to these questions. We are already engaging ourselves into research when we are looking for and into something, when we are comparing and contrasting things, when we are searching for more information, and when we are finding what people think and want. And one aspect of research is to describe and explain variables. So for this lesson, we are going to explore the nature of variables. A variable is a central concept in research. It is a measurable characteristic that changes in value. It may vary from one group to another group, one person to another, or even with the same person over time. A variable is any entity that can take on different values. Quantitative variables are numeric. They represent a measurable quantity. For example, when we talk about population of grade 11 learners in a certain school, we are talking about the number of students in grade 11, a measurable attribute of the school. Therefore, population would be a quantitative variable. Another examples are general weighted average of senior high school students and the growth of pechay planted in Palayan sa paaralan. Another definition is a variable is a characteristic of an object we seek to find out by measuring, counting, inquiring, observing, or computing. The object can be an eye, a person, a mobile phone, or a virus. For example, age is one characteristic of people. You can inquire and verify the age of a person using valid IDs. It is likely that age can take on values between 1 and 100. Any number higher than this, for example, 139 years old, is not likely. 39 years old is more likely. Another is a weight of a person can be measured using a weighing scale. For a typical Filipino with an average height, 50 kilos is okay, but 200 kilos is unlikely. We can usually tell the gender of a person with a look. There may be a 50-50 chance of an object being a male or female, but this may not be true in an engineering course where there are more males than females. Now, let's have more characteristics of people. Observe the color of the eyes. We have black, blue, or green. Our normal body temperature only ranges between 36.5 to 37.5 degrees Celsius. Another example is for educational level. We have elementary, high school, or college graduate. For some, they may be master's or doctoral graduates. Now, let's tackle about types of variables. We have the independent variable and dependent variable. Independent variable is sometimes called an experimental or predictor variable, and variable that is being manipulated in an experiment in order to observe the effect on a dependent variable. It is sometimes called an outcome variable. The presumed cause in experimental study is an independent variable. All other variables that may impact the dependent variable are controlled. The values of the independent variable are under experimental control. Strictly speaking, independent variables should not be used when writing about non-experimental designs. These are the individual variables that the researcher believes may have an effect on the dependent variable. For example, the researcher utilized program instructions in the remedial class. Thus, the independent variable is the exposure of the students to program instruction. Take note that independent variable causes a change in dependent variable, and it isn't possible that dependent variable could cause a change in independent variable. Dependent variable is simply that a variable that is dependent on an independent variable or variables. The presumed effect in an experimental study is the dependent variable. The values of the dependent variable depend upon another variable, which is the independent variable. Strictly speaking, dependent variable should not be used when writing about non-experimental designs. Since dependent variable is the variable that is being measured in an experiment, thus, it is a measure of a certain aspect of a participant's behavior. For example, if the researcher is looking for how remedial class affects performance, the dependent variable would be the participant's test scores. Dependent variable depends on the independent variable. Here is a sample scenario. Imagine that each of these three cups contain the same bottled water. The only difference between them is that orange, green, and yellow food coloring was added to change their appearance. Based on the given situation, let's say a researcher is investigating the research question. Does the color of a drink affect taste? If you think so, how would the researcher go about answering the question? The answer is conduct an experiment, because the research question requires the researcher to look at causal relationships between variables. In this case, the color can cause a change in taste. Researcher must perform an experiment, and only the experimental method can establish the changes in one variable lead to changes in another. In a simple experiment, a researcher manipulates a variable like color to determine its effect. In this case, the variables are both color and taste. As discussed earlier, there are two types of variables. We have the independent variable and dependent variable. Independent variable is the treatment variable that is manipulated by the researcher. It represents the causes of some outcome. In this case, the researcher is only manipulating the color to see if it affects the taste. So, color is the independent variable. On the other hand, the dependent variable represents the outcome that the researcher is measuring. This will be the data that is collected and analyzed. In this case, the response or outcome is taste. So, taste is the dependent variable. Now, before we move on, let's check your understanding of both types of variables. The research question is, does money increase happiness? Pause this video here and identify the independent variable and dependent variable in this scenario. Give yourself a minute or two to answer. Yes, the independent variable is the amount of money. Money represents the treatment to see if it affects the outcome. The researcher can manipulate the amount of money among participants. The dependent variable is the level of happiness. Remember, the dependent variable represents the outcome or response. The researcher has no influence on the level of happiness among participants. Next types of variables are discrete and continuous variables. A variable that can take infinite number on the value that can occur within a population is known as continuous variable. Its values can be divided into fractions. Discrete variable are also known as categorical or classificatory variable. On the other hand, is any variable that has a limited number of distinct values and which cannot be divided into fractions. Discrete variables can be further categorized as nominal and ordinal. Nominal variable is a variable with no quantitative value. It has two or more categories but does not imply ordering of cases. On the other hand, ordinal variable is a variable that has two or more categories which can be ranked. Common examples of nominal variable include eye color, business type, religion, and language. A subtype of nominal scale with only two categories, just like sex, example male or female, is known as dichotomous. For ordinal variable, example is using the Likert scale. If you ask people if they like listening to music while studying, and they could answer either not very much, or very much, then you have an ordinal variable. While we can rank them, we cannot place a value to them. In this type, distances between attributes do not have any meaning. For example, you used educational attainment as a variable on a survey. You might code elementary school graduate is equals to 1, high school graduate equals to 2, college undergraduate equals to 3, and college graduate equals to 4. In this measure, higher number means greater education. Even though we can rank these from lowest to highest, the spacing between the values may not be the same across the levels of the variables. The distance between 3 and 4 is not the same with the distance between 1 and 2. Another examples are, we have the grade levels, social class, and top students. For continuous variables, it can be further categorized as either interval or ratio variables. Interval variable is a measurement where the difference between two values does have meaning. The difference between temperature of 60 degrees and 50 degrees is the same difference as between 30 degrees and 20 degrees. The interval between values makes sense and can be interpreted. Another examples are birth year and time. For birth year, between 2019 and 2020, the interval is 1 year, which is also true between 1967 and 1968. The value of these intervals are the same. This is also true with the intervals between number of hours, minutes, or seconds. Lastly is the ratio variable. Ratio variable possesses the properties of interval variable and has a clear definition of zero. Zero indication that there is none of that variable. Examples of ratio variable include height, weight, and distance. But temperature measured in degrees Celsius and degrees Fahrenheit is not a ratio variable because zero under these temperature scales does not mean no temperature at all. Another examples are dosage, salary, blood pressure, and speed. Example of dosage is 5 milligrams of vitamin C per 100 milliliters. Another is for salary. We have 20,000 per month or the minimum wage of 381 pesos per day. The normal blood pressure is 120 over 80 millimeters of mercury. And lastly, for speed is kilometer or miles per hour. The recommended speed in our highways is only 60 kph or 60 kilometers per hour. So to review our discussion, we have different types of variables. We have the independent variable and dependent variable. Independent variable is the cost variable and the dependent variable is the outcome variable. Another types are discrete and continuous. Discrete is categorized to nominal and ordinal variables, while continuous is further categorized as either interval or ratio variables. Now, remembering the basic differences can help you remember the different variables. Let us all remember that nominal is named, ordinal is ordered, interval has a known interval or difference, and we have ratio has a true zero. So in the table of summary of characteristics of variables, we have to remember the following. So if it is only labeled, then it is nominal. If it is labeled, ordered, and zero is arbitrary, then the variable is ordinal. If it is labeled, ordered, has known difference, and zero is arbitrary, then it is an interval variable. And lastly, if it is labeled, ordered, has known difference, but zero means none, then it is a ratio variable. And to decide what category a particular variable is, let's ask ourselves these questions in order. First, is the variable ordered? If not, the variable is nominal. If it is ordered, ask yourself if there is an equal distance between values. If not, the variable is ordinal. If values are equally spaced, ask yourself if a value of 0 actually means that the variable being measured does not exist. If not, the variable is interval. If the 0 means none, the variable is ratio because the 0 is absolute. Now, let's practice what we have learned. We have the first problem. A patient has a pulse rate of 88 pulse per minute. What category of variable is the pulse rate? Now, let's ask ourselves those questions that were presented earlier. First, is the variable ordered? Yes or no? Yes, because it has numerical value and pulse rate has lowest and highest values. Since it is ordered, let's ask ourselves if there is an equal distance between values. Yes or no? Yes, because it is equally spaced. So, since the values are equally spaced, let's ask ourselves if a value of 0 actually means that the variable being measured does not exist. A pulse rate of 0 means death, so 0 means not existent. Hence, pulse rate is considered as ratio. Next problem is, the top two religions in Jose Tuason Jr. Memorial National High Schools are Christianity and Islam. What category of variable do they belong? Now let's ask again ourselves, are these variables ordered? Can we rank religions? Yes or no? No, because they are equally important. Since it cannot be ordered or ranked, then religion is nominal. Last problem is, a mother gives birth during these years, 2000, 2010, and 2020. What category of variable is this? First, let's ask ourselves, is the variable ordered? Yes or no? Yes, because it is arranged in chronological order, which is year 2000, 2010, and 2020. Since it is ordered, let's ask ourselves if there is an equal distance between values. Yes or no? Yes, because it is equally spaced. For this case, 10 years interval. So, since the values are equally spaced, let's ask ourselves if a value of 0 actually means the variable being measured does not exist. Yes or no? No, because 0 in birth years is arbitrary. So, birth year is interval. Now, you already mastered the different types of variables and its uses. Congratulations for a job well done. Now, we are done with our lesson. Thank you for attending. If you have questions, kindly send it to our Facebook group chat. See you again next week. God bless.